Hi everyone. So here again we will talk about a cheat sheet of algebra. So we will do some exercises using two different vectors, two different arrays, and then we will start doing several operations. For example, multiply them. After that, element-wise operation like addition, subtraction, division, all these kind of operations. After that, matrix element-wise operation, add, product, transpose, multiplication using numpy. So in this video I will show you everything about linear algebra, the basics of linear algebra. So let's get started. So as you see here, we have two arrays. Start creating another one. Product equal, okay, print. We have here first vector, put this here, okay, then have n here, x, take this from here, and we put this second vector. Make the code look more beautiful. So we have here x and y. Then for e, now what we will do is we multiply each one of the components of the array. Product dot append, okay, xi, multiply this by yi, okay, run, take this, format the code, let's run it again. Okay, first vector, second vector, okay, because we need to print this. So go here, print product. We run this again. As you can see here, we have the first vector, we have the second vector, and then the multiplication between them. 1 per 3, 3, 2 multiply 5, 10, and 3 multiply 7 is 21. Okay, so let's moving. So now this is the manual multiplication. Now we will use linear, we will use here linear algebra version. So I start using this version right now. Okay, so here x equal mp dot array, and we put here the array, copy this from here, paste it there, take this and we put it here, copy this from here, and we put it there. As you can see, okay, we have x and we have y. Now we will do all the operation of element-wise operation. Okay, so we put here a comment, element-wise operations like addition, subtraction, and division. Okay, we have now. So print, we have the product product here, x multiply this by x by y. So we have a couple of operations here. We need here 4 operations: product, addition, subtraction, and division. So let's do it. And then the last one is the dot product of 2 vectors. Okay, so keep moving, baby, keep moving. So we have this one. So we have here addition, we have here subtraction, okay, and then we have here division. So this one, addition, subtraction, okay, we have here subtraction, then we have division. So this is the linear algebra version, and this version we will use here NumPy. Okay, so let's run this again. Check this out, ladies and gentlemen. So you see here 3, 10, 21 product, 4, 7, 10. So if you add this 1, 3, 4, 2, 5, 7, 3, 7, 10, and this, if you subtract it, 1, 3, 2, 2, 5, 3, and 3, 7, 4. And then we have here the division. Okay, check this out. So here we say that we have the operation of product, addition, subtraction, and division. So ladies and gentlemen, the next step, we will do the dot product, and we will see the operation of the matrix dimension, the operation on matrix. Okay, let's check this out. So here you see print. Okay, we have dot product. Okay, so here we have mp dot x comma y. So if we run this again, you can see here, okay, so the dot product is 34. Okay, our dot product is 34. So let's go and do the operations of let me see this one, enter presentation mode. Okay, ladies and gentlemen. Okay, so this one here now, we will do a matrix dimension. Okay, matrix dimensions. So we create here a simple matrix, mp dot, okay, we choose array, and then in the array we put our matrix 1, 3, and then 5. This is the first row, and then the second row, what we do is we put 7, 9, 11. Okay, and then we close the matrix. Let's do it here proper way. This one. Okay, we have this now, then we have this here, and then close it proper way. Okay, that's it. This is our matrix. Take this, and then take this. Okay, and then we reformat the code. So now we have our matrix, first matrix. Look how beautiful it is, how wonderful it is. So now we go and print the dimension of the matrix, dimension of matrix A. Okay, so A dot shape, ladies and gentlemen. So we go here outside this, exit presentation mode, terminal. Let's go again, see the enter presentation mode, exit presentation mode, and we run this. So run this again, and if you see here the dimension of the matrix, which is 2 and 3. Let's check this again. Appearance, enter, destruction mode. No, this is not. Enter presentation mode, and then run. Yeah, okay. So if you see this here, okay, you see that we have the dimension 2 and 3 because we have 2 rows and we have 3 columns. So let's keep going. Okay, here again, print. Here I will print you the matrix, all the matrix, and then we will add another matrix and we do a couple of operations. First matrix we have here N, then we have A. So now we go and we print the matrix. So we see the matrix 1 3 5 7 9 11 7 9 11. Okay, go get here, and what we will do here, we will add another matrix, just call it matrix B. So we take this from here, copy this, make it more quickly, call this B, and then we will do, just it will be different. So here we will have 3 rows and 2 columns. So take this from here, okay. Here we will have 5, then 7, and then we will have here 9, and then 11. Okay, so this is our new matrix, and the same thing, we will see the dimension of the matrix, and then we print the matrix. We take this from here and we put this here, ladies and gentlemen. B, this is B, this one. So you will see now the difference in the shapes. Okay, let me see here, what is the problem here? So okay, this is the problem, it's always a comma, sucks, always a comma. So let's change this, second matrix, print this. Okay, so now if you see the second matrix, there is a difference because here we have 3 2 and the other one 2 3. So the first one is 2 rows 3 columns, the second one is 3 columns and 3 rows and 2 columns. You see 1 2 3 3 rows and 2 columns. So let's go now and create another matrix, which call it matrix C. Go again, copy all this from here, put it here, we call it C, delete this, and then we have 1 1 1, then the second row, the first row 3 1s, the second row 3 2s. Take this, format the code, we put this here C, put this here C, and this is our third matrix, which is the matrix C, third matrix. So if you see here, this one is the same the first one, 2 3. You see we have 2 rows and the 3 columns, and this is the third matrix. So now we will play with the matrix and we will start doing a couple of operation. So our first operation here is matrix scalar operations. Okay, print. So the first operation is a scalar. Matrix scalar operations, add 1 to the matrix A. So this will be our first operation. We take the matrix and then we add 1 and we print it. So if you see, we add 1. If you see the first matrix, which is this one, 1 3 5 7 9 11, we add 1 to each one of them, so we will have 2 4 6 8 10 12. This is our first operation. Then the second operation is matrix element-wise operation. So this is different from the first one. Matrix element-wise operation. What happened here? Okay, he didn't like it. Print add to matrix. So what we will do here, we will add A plus C. We will add these two matrices. Add the matrices, and then you see here. So we add both of them. We have 2 4 9 11 3. Because if you see the first one, and is this is the first one, and this is the second one. So if we have the result of the first one and the second one, we see you have 2 4 6 9 11 and 13. That's it. So now let's talk about another kind of operation. We call this broadcasting. Okay, now we have the operation of broadcasting in NumPy. We will use NumPy here. So our first matrix using NumPy, we call it M1 MP array, and here we put our matrix, which is the first one 1, and then the second row we put 3. We will do the same thing we will create another 2, which is the second one and the third one. Okay, so print first matrix. We have M1. So here we print this. Okay, so we will do the same thing here. Okay, so we have here 2 and we have here 3. In the second one we will have 5 and 7. Okay, and this one we will have 9 and 13. So second matrix. Then in the third matrix we have only one row. which is 1 and 3. This one is the third matrix. Okay, so if we print this here, you can see it. First matrix, second matrix, and third matrix. We have to change this as well. And we have here first matrix 1 3, second matrix 5 7 9 13, and 1 3. Okay, so now we have same number of rows and different number of columns, but M1 has one column, so this is all works. Okay, we will do broadcasting here, which is we will try to multiply with different number of rows of columns. Okay, same number of rows but different number of columns. So let's start with the first example. Print here broadcasting same number of rows. Okay, we have M1, multiply this by M2. So if you see this broadcasting same number of rows, we see that the first matrix we have 1 3, and the second one, okay, we have 5 7 9 13. So we multiply 1 by this, and then we multiply 3 by this. We have same number of rows, which is 2, but different number of columns. Okay, put it here for you. Same number of rows but different number of columns. We will do another operation of broadcasting. Here we have same number of columns, in the other one we have same number of columns and different numbers of rows. So same number of columns, which is this is have to be 2 and 3, but different number of rows. Do this broadcasting again, and we see this again. So this is the third matrix. So we take this 2 and multiply it by the 3. Multiply these 2. So we have 5, 21, and we have 9, and this is 39. Okay. So now we do another operation of broadcasting, which is different totally from the other two. Take this, put this here. We have now different number of columns and different number of rows. So multiply this one by 3. Okay, so we have to put this same number of columns, and we change this here, different number of rows and columns. We see this same number of rows, the first one, which is M1 by M2, so both of them have 2 rows. Okay, the second one, if you see, same number of rows, both of them have 2 rows. This is 2 rows and this is 2 rows. The second one is same number of columns. This one have 2 columns and this one have 2 columns, and the third one there is no either. Rows and columns are different. So if you see, this is the multiplication, 1 3 and 3 9. Okay, so we finish in this operation, and now we will have to go and do another operation. Let's do this operation now. So this one is matrix had marred product. Okay, this is had marred product. So we create here another one. Let's copy this from here. M4 equal MPRI. So here we have 2 3, and then we have here 2 3. Okay, then we have this another one, which is, we call it 5. Let's take this from here, ladies and gentlemen. Take this from here, and then this is, call it first matrix, M4, and then another second matrix. Call this second matrix. Okay, and in this one what we have to do is 3 and 4 and 5 and 6. Both of these, they have the same number of columns and same number of rows. This one is, if you check this out, you see 2 3 2 3 3 4 5 6. You have the same number of rows, same number of columns. So now we print our matrix had amard product. Okay, this one, and then we have M, multiply this, M4, multiply this by M5. Okay, this one. Okay, you see 6, 12, 10, 18. So multiply this is 6, this is 12, and this is 10, and this is 18. Okay, let's move on now to the other operation. So we still have a couple of operations to finish. So one of them is the transpose, and the other one is the multiplication using NumPy. So let's see it again. Now matrix transpose operation. Okay, so let's choose this, for example. Let's copy this here, make this more easy, more quickly for you. You can do it yourself and enjoy yourself doing this. 1, we have here 2, and then we have 3, here we have 4. So you need to print the original matrix and then the transpose. This one is, call it original matrix, which is M6, and then we have here transpose matrix, which is this one, M6T. Okay, you'll see the difference. You see, this is the original one, 1 2 3 4, and the other one have to be 1 3 2 4. We do it good. Let's move on now and do the matrix multiplication using NumPy. So M7 equal MP dot array. Okay, and then here we choose simple matrix like 1 and 2. This one have 1 row, 2 columns. Then take another one. Let's take this from here, the same thing. Okay, put this here. First matrix, M7. Take this from here, put it here, 8, and we put here, for example, this is 3, 5, and this one is 7, 9. Okay, so this one, put 8 here, first matrix, second matrix. And then now what we will do is we multiply these two matrices using NumPy here. We will use NumPy. Let's take another one. Let's scroll here. Let me see. Dimension. I like dimensions. Magical dimensions. Dimension of matrix 7. Put here 7 dot shape, and then have the dimension of M8. You will see here something really amazing, awesome. So see, the first one have a dimension of 1 row, 2 columns. The second one have a dimension of 2 rows and 2 columns. So if we multiply this, we have a result of 1 row, 2 columns, because these have the same number of columns. Okay, so now if we go and multiply this, let's call it final, and then we put here mp dot, we put here m7 m8, print, and then multiply two matrices n. Okay, here we put m final, and then we put here the dimension. Let's put this here, dimension of the final matrix, here m final. Now check this out. So the result is 1723, and we have 1 to the dimension. So we finish here. Thank you, ladies and gentlemen, for following me. So we started by multiplying two arrays. After that we did element-wise operation like product, addition, subtraction, division, and dot product. After that we use operation on matrices. So if you see here, we have 3 of them. Like the first one is element-wise operation, we add this, and then first on this one, sorry, we add this, and then the second one is we add 2 matrices. After that we have a broadcasting and numpy. We give you an example of 3 matrices, and then we did different type of broadcasting. Same number of rows, same number of columns, different number of rows and columns. After that, the HADMAT product, first matrix, second matrix. It have to be the same number of rows of columns. The transpose matrix, check this here, and last one, which is the multiplication, use numpy. So we create 2 different type of matrices, but one of them have 1 row, 2 columns, and the other one have 2 rows, 2 columns. So it have to be the same number of rows or same number of columns. Here have to be the same number of columns. Thank you very much, and I see you in the next section.